So now, one thing which is very clear is that most of the physical systems in the world, may it be electrical, mechanical, are governed by differential equations. And for a given system, if specified input is given, what the output will be is to be determined by you. That is number one. That is called as analysis. System is given, input is given, what the output will be is analysis. Whereas input is given and you want that particular output. For that, what should be the system? That is called as synthesis. Analysis and synthesis are two things. Analysis is simple like derivative, synthesis is somewhat difficult like integration. So, solving this differential equation and all those things is a very classical mathematical process, and even though you might have studied it in standard 12, that time your approach was to crack the seed. So differential equations and all that was not done from that point of view. So solution of differential equation to some extent is an art, means there must be some intuition. Listen very carefully. Look here and don't cross talk. That there is no standard procedure by some kind of classification and overall study. Some methods have been proposed, but there is no standard for finding derivative. For finding derivative, there is standard procedure. Like that, even for integration and for differential equation, it is somewhat difficult. Therefore, what we do is we skip that part for the time being. It is when we come across some difficult things, what we do? We put for option and proceed further. When I say that, what I mean is that because of the substantial advancement in digital things, now there is a clock is there in the class. When students did not have wristwatch and they were very much enthused for the lecture, they were eagerly waiting that they should get more and more time, and they were watching at that clock. But now, with wristwatch in your hand or in mobile, that has become redundant. Like that, or few decades back, I repeat, that to understand the clock having small hand and big hand was considered to be a skill to be imbibed by the students going in the age group of 4 to 7. Who knows it is called a smart student, smart guy or smart girl. But now that is becoming irrelevant. Like that, why that is becoming irrelevant? Because we have directly digital clock. Like that, since the entire systems have changed, we have got digital systems. So the differential equations have been reduced to difference equations. Is the idea clear? Differential equations are reduced to difference equations, and difference equations, the moment that then somebody will say, how will you solve difference equation? Can anybody tell? Differential equation is to be converted to difference equation. How? That all variables are not existing in continuous form, only sampled values are taken. So a continuous function xt is converted into a discrete function or an array or a set of numbers xn, x0, x1, x2. These are continuous values, these are real variables. So that discrete equation can be solved only on paper. It can't be realized in practice. But that discrete is quantized using ADC. So you get, means what ultimately we get is a digital signal. Continuous signal both amplitude and time axis are continuous. Discrete signal, amplitude axis continuous but time axis discrete, and digital signal, both axes are discrete. So what I see a signal here, if I draw it continuously, what I get using sampler and ADC is an array of numbers which is stored in computer, so that you can very easily handle. So we now again, when digital signal processing was introduced, if you go through some papers, research papers in 1970s, that time the problem was when you look Shannon's theorem, you understand what that is. That is the mathematical theory of communication. After that, the issue was discrete things, means discrete time signal processing is only an academic branch existing on paper but can't be implemented. Therefore, its implementation, that discrete needs to be quantized into digital thing. ADCs were not available to this extent at time. So hardly, very slow ADCs in some kilo samples per second and 8-bit or 16-bit per sample. That was ADC available. Large resolution, means very good resolution ADCs were not available. So that time what was happening, because of the finite length of the one value, there were errors and it was having an impact. So that time research was on what you are signing? You are signing for yourself or somebody else. So what we can say particular. Anyway. That effect of finite word length effect was a research area. But now what has happened? It is so cheap, means earlier when there was color camera, very few photographs are to be taken because it was costly. So which photographs, that was a decision to be made. Now you are having the digital camera, it doesn't cost anything. So you can have all auto snap photos also. So that is the difference now. So now the resolution, the AD, so much good quality ADCs are available both in resolution and sampling speed, that we hardly see the difference between digital, continuous and discrete. So that issue is almost gone, and once that idea is clear, these differential equations first is to be converted into a difference equation, and this is something which is very easy to understand. And how to solve the difference differential equation? No solution needed, because difference equation itself is a solution. Difference equation itself is a solution. By solution what we want? Suppose we take a standard differential equation. What is the standard differential equation which we were talking? d VOT upon dt plus VOT is equal to V. This is to be solved. To be solved means what? Solution means you want to express, this is differential equation. VOT is there but not in direct form. So what is solution? Solution is you must have VOT on the left hand side and on the right hand side everything else which should not include VOT. Right? Means VOT must be expressed in terms of VT and something else, right? So that is the expected solution. That is difficult. What I repeat is he solved, but not on his own, by using standard methods. So you should try to find what is the solution. The solution must evolve. But let us keep that apart because that is not required, and we go for the difference equation. So in general, last time I have taken, but this is most important. So in the actual classroom, I may repeat few things which required heavy bombardment. Right? So the question. So now I write a question. I put I put the video on pause mode. So those in the classroom will solve right now. Those who are watching the videos in absentia will solve, and then they can again check, and those who are present and again want to see the video can again solve. Is there any such student who is present in the classroom and again wants to watch the video for consolidation of the concepts? The question is, convert the following differential equation into difference equation. When I say differential equation, I specify it more that between V in T and VOT, and this difference equation is V in N and VON. And derive the expression for VON, where in general VON is equal to VOT, where T is equal to N delta T, where delta actually capital or small is not so important, let us use small, delta T, where delta T is sampling interval and sufficiently small. Is it clear? So now we put a pause, you solve, and then we discuss.